Hello, we're going to look at Lesson 2-1 notes on properties of exponents. We're going to learn several different rules, about 5 different rules today on the different properties and characteristics of exponents. We know that 5 to the third power, or 5 cubed, is 5 times 5 times 5. In the example above, 5 is called the base, and 3 is called the exponent. Our first rule is any number that is raised to the power of 1 is equal to itself. For example, 8 to the first power is equal to 8. 50 to the first power is equal to 50. Second rule, any number raised to the power of 0 is equal to 1. Doesn't matter what that base is. For example, if the base is 12 and it's raised to a power of 0, the answer is 1. If the base is 100 and it's raised to the power of 0, the answer is also 1. So anything raised to the 0 power is equal to 1. Third rule, when like bases are being multiplied, their exponents can be added together. So if we have x to the a power times x to the b power, then you would add the a plus b. We're going to do some examples of those in a little bit. Our fourth rule that we're going to have is dividing like bases. So when like bases are being divided, their exponents can be subtracted. So for instance, if you have x to the a power over x to the b power, you would have that equal to x to the power of a minus b. And our last rule today is going to be power to a power. So when an exponent is raised to another exponent, the exponents can be multiplied. So you're looking for parentheses with an exponent on the inside of the parentheses and an exponent on the outside of the parentheses. Those exponents will be multiplied together. So let's put these rules in action. Keep referring back to them. So on number 1, I have 8 to the 7th power times 8 to the 3rd power. So what we learned up top is when we're multiplying like bases, we will add the exponents. So 8 to the 7 plus 3rd power. That's going to give us 8 to the 10th power. On number 2, we're dividing. So the rule says that when we're dividing like bases, we're going to subtract the exponents. So I'm going to have 9 to the 9th power divided by 9 to the 6th power, so I'm going to subtract those bases, and that's going to give me 9 to the 3rd power. When you're looking at number 3, look at the different rules that you have. Which one is it? Okay, it is the power to a power rule. Okay, so I have 4 to the 8th power raised to the 2nd power. So I'm going to multiply those exponents. So that's going to be 4 raised to the 8 times 2. That's going to give me 4 to the 16th power. Number 4, I've got this m raised to the 0 power. Well, I know that anything raised to the 0 power is 1. So that's going to be m to the 3rd power times 1. Or that's going to simply give me m to the 3rd power. Okay. Also, if you're using the multiplying like bases, it's going to be m to the 3 plus 0 power. Still gives me m to the 3rd. 2 ways you can do that one. Okay, on number 5, I've got a whole lot going on here. So I'm going to do the numerator first. So I'm going to look up here, and I've got 7 to the 2nd power times 7 to the 5th power. Well, if I add the exponents, I'm going to have 7 to the 7th power over 7 to the 3rd power. Okay, the next thing that I need to do is I am dividing like bases, so that's going to be where I'm going to subtract the exponents. So that's going to be 7 to the 7 minus 3rd power, so 7 to the 4th power. Again, I've got two things going on number 6. If I'm going too fast through any of this, just pause it until you have an opportunity to catch up. But number 6, I'm going to use the power to a power rule on the first part. So b to the 5th power raised to the 3rd power. The rule says that we're going to multiply those exponents. So that's going to be b to the 15th power times b to the 4th power. Okay, so now I've got another rule. That rule is going to be multiplying like bases. And when we multiply like bases, we add the exponents together. And that will give me b to the 19th power. Okay, number 7. Got two things going on there. I've got division of like bases, and then I'm going to multiply like bases. So let's do the division first. I've got 15 to the 4th power divided by 15 to the 2nd power. I'm going to subtract the exponents. That's what the rule tells me to do. And I'm left with 15 to the 2nd power. Bring down the 15 to the 7th power. Okay, so now what I'm doing is I'm multiplying like bases. What do we do with those exponents? We add them together. So that's going to be 15 to the 9th power. All right, let's take a look over here. I have w to the 2nd power, and I'm raising that to the 1st power. Then I'm going to multiply that times w to the 0 power. Okay, so the first part, I have power to a power. So w to the 2nd raised to the 1st, I'm going to multiply those exponents. So 2 times 1 is 2. I'm going to bring down the w to the 0 power. Now you know there's two ways you can do that. You can simply say 2 plus 0, because we're multiplying, so our rule is to add the exponent. So we can say 2 plus 0 is 2, so that's going to be our answer. Or we can change the w to the 0 power to a 1, and anything times 1 is itself. So either way, you're still going to get w to the 2nd power. These should, I would hope anyway, be kind of easy for you as long as you're looking at the rules. Once you get the rules down pat, they'll really be easy for you. Okay, let's look at some more examples. So flip over your page to number 9. Okay. And what we're going to do here is we are going to add the exponents again. Okay, because we're multiplying, our bases are the same, so we add the exponents. That's going to be 5 to the 4th power. Okay, it does tell us not to leave exponents in our solution, but we're going to anyway, just until we get this down pat. Number 10, we have 9 to the 5th power over 9 to the 2nd power. Look at your rules and figure out what do we do with the exponents. Good, we're going to subtract them. So 5 minus 2 will be 3, so that's going to be 9 to the 3rd power. Okay. Number 11, power to a power. Okay. In the numerator. So we have 2 to the 3rd power raised to the 2nd power. All right, so what do we do with the power to a power? Multiply those exponents. So that's going to be 2 to the 6th power over 2 to the 5th power. Now we're dividing. So that's going to give us 2 to the 1st power, or just 2. Why don't you try to do the next 3 by yourself, pause the video, and then come back and see how you did. Okay. welcome back. Hope you did all right. So on number 12, we're going to have 8 to the second power times 8 to the 0 power, and that's going to give us 8 to the second power. You add the exponents. On number 13, had 1 to the 8th power times 1 to the 12th power. And when you multiply your like bases together, you add the exponents, you get 1 to the 20th power. By the way, do you know what that answer would be? 1. And then on the last one, we have 6 to the 9th power in the numerator, so there's nothing to do there. But in the denominator, we do have to use the power to a power rule. So I'm going to keep the 6 to the 9th power. On the bottom, that's going to be 6 to the 6th power because it's a power to a power rule. Okay, subtract those and I get 6 to the 3rd. Hopefully you did okay with those. All right. Now 15 through 18, okay, these are true-false questions and we have to describe why it would be true. So we're trying to see if x to the 4th power raised to the 3rd power is the same thing as x to the 3rd power raised to the 4th power. So both sides, the left side of the equal sign and the right side, are power to a power rule. So on the left side, 4 raised x to the 4th raised to the 3rd power, we're going to multiply those. That's going to give me x to the 12th power. On the right side, x to the 3rd power raised to the 4th, guess what that gives me? X to the 12th power. So are they equal to each other? Yes, they are. This is a true statement. Let's take a look over at number 16. I've got multiplication on the left side. I've got power to a power on the right side. So if we're multiplying and our bases are the same, we add the exponents. On the right-hand side, we have power to a power. We multiply those exponents. So I'm going to assume that this is false, but let's go ahead and prove it. 13 to the 4th power times 13 to the 7th power. I add the 4 and the 7, and I get 13 to the 11th power. Okay, down on the right-hand side, I have 13 to the 4th power raised to the 7th. I multiply those exponents, and I get 13 to the 28th power. Those do not equal each other. This is false. Okay, let's see about this one. There's a few different things that we have to do. We need to simplify the numerator. So I have y to the 5th power times y to the 0 power. So I'm multiplying. Bases are the same, so I add those exponents, and that's going to give me y to the 5th. Okay, y to the 3rd stays on the bottom. On the right-hand side, I have y to the 2nd power raised to the 1st power. So power to a power, I multiply those exponents, and I'm going to be given y squared, or y to the 2nd power. Okay, well, when I'm dividing bases, like bases, I subtract the exponents. So on the left-hand side, I'm going to have y to the 2nd power, because 5 minus 3 is 2. And on the right-hand side, y to the 2nd power. So this one is true. Let's see about the last one we have here. Have q to the 0 power times q to the 5th power divided by 9 squared. So let's go ahead and solve the numerator on this one first. If I'm multiplying my bases, I add the exponents. So that's going to be 9. 0 plus 5 is 5. 9 to the 5th power over 9 to the 2nd power. Okay, thought that was q earlier, but that's a 9. All right, then I have 9 cubed raised to the 2nd power. That's a power to a power rule, so I have to multiply those exponents. So that's going to be 9 to the 6th power. And in the denominator, the 9 to the 3rd stays. Okay, so on the left-hand side, my bases are the same. I'm dividing, so I subtract those exponents. That's going to give me 9 to the 3rd power. Do the same thing on the right. Subtract those exponents, and I also have 9 to the 3rd power. So these are true statements. Okay. Again, if you keep your rules beside you and go through the notes as you're doing the prep work, you're going to be in good shape. But there are a couple kind of weird things that you're having to do that I feel like the lesson notes didn't go over. You're trying to find X in all of these questions. So for instance, let's take a look at number 4. We know that what we're doing is we have 6 to the 10th power divided by 6 to the x power. That's going to leave us with 6 to the 6th power. So when you're dividing like bases, you subtract those exponents. So I'm going to have 6 to the 10 minus x, and that's going to give me 6 to the 6th power. So basically, you're kind of doing a one-step equation. You're trying to think in your head, 10 minus what number is going to give me 6? Because my answer over here is to the power of 6. Okay, so hopefully you'll recognize that that answer is 4. Okay, so sometimes they get a little bit more difficult. So let me kind of set you up on number 8. Number 8, on the left-hand side, I have 2 to the 6th power times 2 to the 12th power. So I'm multiplying, my bases are the same, so I have to add the exponents. That's going to give me 2 to the 18th power. Okay, over here, x, this is power to a power, so x times 2 is going to give me 2x. So this is going to be 2 to the 2x power. So think of it this way. Basically what you're doing is to find x, you have 2x is equal to 18. It's a one-step equation. So what is x going to give you? Divide each side by 2 and you'll find out. Okay, so I want you to do a couple of these prep work problems. Ask us if you're having any difficulties and we'll be certain to help you out.